Now that we're back in Unity, now that we know that we have labels, now we want to instantiate the thing. So how do we match the instantiation item with our labels? First, what labels do we have? We have sofa, table, wall, door, floor, ceiling, and unknown. Unknown's not really used right now. All windows or doors. And sofa tables are volume objects, so they'll give you an extent that has a vector 3, so x, y, z. And the anchor is actually located on top of the volume. So right in the volume, and then the z-axis is actually pointed up from the volume out. So the blue arrow will be pointing up. You can get this information by using get anchor volume info, use our anchor handler, and then you'll get a center of where the volume is from the anchor point. And the extent is also from the center. So we know these values are actually relative. So first we can set the item into the instantiated new item that we have called new sofa. We'll set it as a child of our anchor object. And since we know that the center is relative to the anchor object, we can actually move it down. And then if we do the rotation, now the sofa is facing up as well. Then the scale, how large for the volume, all we have to do is just set our local scale to the extent, because the extent is relative to the anchor. So sofa, table, both of them are volumes, so relatively the exact same thing here. Now walls and windows and doors are going to be different because they're going to be taking a plane information. With the plane, instead of a vector 3 as our extent getting information out, it's actually a vector 2, only x and y. X and z, actually. Sorry. So we'll just manually set the y, which is our height. Walls are very thin, so we don't really need to care about that. Again, the anchor is going to be located at the center of the plane here. And now we don't actually move to the center because it's not a volume, it's a plane, so it sits right in the top, right in the middle. This one, instead of get anchor volume, this will be get anchor plane boundary info. Same thing with a key, you get a center and you get an extent. So we don't actually need to grab the extent, we can actually just take the anchor object, set the parent, and then we'll just reorient ourselves to the anchor object just by resetting our position, and you automatically become the center. All right. Same thing with the rotation. Set it to identity. It will face us. The anchor is facing the correct direction. We're now a child of it. Should be fine. With the wall, you actually have to rotate. Once you get there, you want to rotate by the x-axis by 90 degrees. And then the scale be the exact same thing here, but our transform is in XYZ. We have our extent is in vector 2. So we just set our x and z value to the extent, and then the y value is just the height of our wall. I just set it for very small numbers. I just do 0.001 here. You can change and mess with this however you want. And yeah. So walls, windows, and doors will be the same thing here. In the furniture option, you had an option between the window and door. It's just going to be labeled as a door. Oh, and also if you need to, I usually increased my wall height just a little bit, just in case there's any gaps or anything like that. I want my wall to cover any gaps there. So since the walls and doors are the exact same thing, so I just copy and paste it. Now I just change the prefab name. Go ahead and clean it up a little bit. There you go. So the windows and doors, I don't actually need to extend the Y value, so I just set that back to normal. So in the current SDK, the floor and the ceiling is not available, but the anchor information is available. Just kind of set this up. I'm just going to copy and paste the information from the door. In the future, you'll be able to use get anchor plane poly information. For now, we'll just copy this for now and just so we can have the instantiation. We actually don't need the boundary information or volume information. None of that actually helps us. Let's first make a prefab for our floor and ceiling. What's important here is we're actually using the anchor object and setting our new floor ceiling object as the child of our anchor object. That's the most important part there. So all this information is filling. Actually, as I said, you don't really actually need to get plain boundary info, but I'll just keep it there for now. So right now I know this is not aligned correctly. So for most people, you're going to be creating some kind of box, say, for, 4 sides, a rectangle. So what we can do, if you are creating a square, we can grab all the walls. So at first, let's make a list of all the wall anchor objects. As we are finding the walls with the labels, we're going to add them to our list. Then we're going to use the walls to help determine which ones are opposite each other, longest sides, right? So let's call it calculate scale sides. So the idea for this is we're trying to find the 2 points, 2 walls are the farthest distance away from each other. We'll set that as our, the longest wall. Then we'll have 2 walls left, and that will be the other distance we have. Then we're going to use those information to find the sides of how wide our plane should be. So let's go through, just make a list here. We're going to calculate the distance between all the points. Can anybody tell me the speed of this for loop here? All right, now just grabbing the distances, storing the distances in our new list. Once we're finished, just sort by the distance. We're going to know that the longest distance here will be the longest points from 2 wall objects, most likely the widest part of our rectangle or square. Now that we know in our sorted list, the longest pair is the 0 index. So our depth, the widest part, is going to be the 2 pairs and the longest pair here. And then since we know these 2 walls are the longest pair, then the remaining 2 walls, we're going to use that to calculate our width. So let's just make a random list of those indexes, remove the 2 that we are using, whatever left over, I'm going to use that to find the width. Now just remember, this only works if you have a square, rectangle. If you have like more than 4 sides, probably don't use this. So we're going to return the vector 2, same thing as before. We're going to use it as our x and z value to scale our walls, or to scale our floors and ceilings. Just like how we did with the walls. Scale ceilings. Go ahead and calculate sides. So when do we want to do this? At the end of everything after we get all the 4 walls. So which ones are, how do we know the floor and ceiling transforms? Let's cache those values. Once we find a floor and once we make it, Let's go ahead and cache that as our transform here. Same thing with our ceiling. And the exact same thing as we did before. Same thing for the floor here. Now, the rotation is gonna be off by just a little bit. So I've done a few testing. If we just increase the size relatively just a little bit more, we're able to cover all the corners. The whole idea is we want to make our the space calibration like a box where we can set the colliders for the ceilings, walls to make a complete box around the user. That way they can start interacting with the world with Unity objects and Unity logic. And that should be it. Double check everything. Now all those prefabs. So we had the blue prefab earlier. Make sure you have a box collider and a rigid body, and make sure it's set to kinematic. So the idea for these things is what for the walls and everything that we're creating, it's actually looking for a primitive cube. So the scale has to be 1, 1, 1. This is very important. So don't forget this when you guys are making prefabs for the walls and the ceilings and everything else for the spatial calibration. It has to be a scale of 1, 1, 1, basically a primitive cube. Instead of using primitive cube, I make my own just because I want to be able to color code it and label and show it for you guys. I'm just going to make a bunch here, then I'll just change colors. Again, in the current SDK version, the desks are going to be called tables, and couches are sofas. And I'll make some tags just in case, you guys want to grab these. You're able to hit these walls, or you're able to, in your logic, if you want to do something specific, some kind of reaction off the floor or a reaction off a wall, you can do that here. Go ahead and set your tags. Walls, windows. Okay. Let's just give everything a little bit different colors. So right now, see-through doesn't handle transparency layers very well. You're going to have a race where things are trying to render on top of each other, and if you have too many translucent items, transparent items, you're going to actually render all of them at the same time. So you actually have to change the render queues a little bit, make some things render forward. But if you have too many things, you're going to have to decide which one of these things have to render at different layers, called the render queue. So just give you an example of what it's going to look like. So let's start adding our prefabs. So the materials are transparent here, setting our prefabs for our spatial calibration. Go and save, build. All right, just press play. I always try to press play before I build just to see if I have any errors, I miss anything. All right, now you can see the transparency is off. Everything's kind of rendering on top of each other. Not what we're looking for here. So let's go back to Unity. Let's turn all these surface types into opaques. Make sure you get to everything. And as I said, make sure you switch the surface type into opaque. And build. And this is what you're going to get. Something of this color, depending on what color you get. It doesn't really matter too much about the color. But the idea is that you're able to see the primitives relatively to the correct size of walls that you actually measured out for your windows, for your sofas, for the walls and everything. That's what we want. So now that we know the walls are correct, the sofa's correct, and everything's there, now we want to hide everything. We don't want to show these things anymore. And so then it'll be part of that, give you that mixed reality feel where you still get that collider and the collision of your real world objects, but you don't need to see the actual meshes, the Unity meshes. So let's do something fun here. Let's create a quick shooting script. So again, show just different ways to kind of show you that, we're able to interact with these meshes with Unity objects that we're creating with spatial calibration. Create a quick bullet, reduce the scale here, give it a rigid body. I think a green bullet looks nice. Give it the bullet script. I just don't want it to stick around for too long just in case it flies through the wall. The walls are kind of thin, so right now there's a good chance these bullets, if you make them fast enough, it's going to fly through the wall. And that's fine for now. Give it a quick lifetime. On enable like when it instantiates. Give it a lifetime, and then it would just kill itself. Okay, looks pretty good. Let's go out of prefab. Just note the scale is 0.2, 0.2, 0.2. That position doesn't matter because we're going to set the position and shoot it. So where we're going to shoot it from, create a child. Let's just call it like the some kind of left spawn point, left shoot point, something like that. Somewhere 0.5, 0.2 around in front of your controller should be the right spot. I think right now I'm doing 0.5 and the Z value, 0.2. Okay, and then shooting control here. I'm gonna grab those transforms that we just made. These are gonna be our spawn points for our bullets. Let's grab the bullet screen. Usually if it's like I'm grabbing like a public transform from the hierarchy, I just make it public. If it's like a data type in my class, I'll make it private, make it serialized. Everybody has their own thing. Just setting up my namespaces here. And I want to be shooting with my controller here. So left trigger, right trigger. Those are require some input action references. I go a little more in depth in my previous videos. If you want to go more in depth on input action references, input map, button mapping, check out the other YouTube videos we have available on our YouTube channel here. So what do we have on left shoot? Yeah, the enable is ready right now just because we don't have the right callback, but we'll. Oh, yeah. Left bullet here. So let's take care of left shoot, then we'll do the actual left trigger. And there's your body. Add force. And you want to do force with the impulse here, and direction forward. Make sure you multiply it by your bullet speed. Looks good. Okay, that's the left. So what I'd like to do for these left trigger things here is have the callbacks only for the left triggers, and then that way I can have multiple scripts, multiple methods inside my left trigger, multiple left methods inside my right trigger, just in case. A little bit easier to organize this way. And make sure you subscribe to the event, and the event you subscribe to make sure you desubscribe on enable and disable. Let's do the left shoot. Let's do the right shoot here. I'm just doing it a little bit different because I want the bullet speed on the left to be faster, the bullet speed on the right to just be a little bit slower, just to give you a little more visual. On right trigger, and right shoot. That's my right. And now I just gotta do my right trigger here. subscribe to the event. And the event I subscribe to, gotta desubscribe. Okay. And go ahead and go find these, add these points from the controller. Add our bullet prefab. Left thing is the left trigger. And right trigger. Go ahead and look in our input action map. It's a button. In the path here. Make sure it's usages. Go to XR controller. Beacon controller, left or right. This one's right. Usages, capital U. Make sure the here is capital T. Left, usages, trigger button. Great. Left, usages, trigger. Okay. Go ahead and save this. Actually, I want to turn on my windows for now, just to give you some visuals. Now imagine where the yellow will be enemy portals. Maybe all windows are portals. You can see here the ball actually rolls behind the sofa, but because we don't have occlusion, you can able to, it's going to render through that. So right now the green ball is able to interact with the walls, bounce off my wife's head. But as you see, the walls work, but the problem is occlusion. So how do we make occlusion? Let's go ahead and go create a new material and go to shader, VR, spatial mapping, occlusion, set the geometry, the render queue to something below 2000, like 1998 or something like that. And then all the sofas and tables that we want to have our occlusion, add our new material we just created. Make sure the mesh render is on, but with the occlusion. Go back, do it. Then I just redid the sofa, so it'd be a little bit easier to see. So it bounced off the sofa and it drops behind the sofa and rolls. So now we have some occlusion. Awesome. So what else can we do with this type of mixed reality, right? We have spatial anchors. We have some occlusion. What if we made a game where we combine some kind of spatial anchor, something move in space, same thing where maybe like the balls rolling, some kind of rolling game with some occlusion.